Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. I want us to be in a position of looking at this type of question now. After looking at the graph type of question, so yes, I want us to be in a position of knowing very well how these questions taken from exam are answered. Let's just dive into it. A wooden trolley of mass 2.7 kg, okay, moves to the left with a constant velocity of 3 meters per second. Okay, they've given us a bullet of 0.03 kilogram is fired horizontally from left towards the trolley, from left towards, okay. See diagram 1. The bullet strikes the trolley and comes to rest here inside the trolley in 0.02 seconds. So now I have a change in time that I will need during when they say I should calculate maybe the force. Okay. The average net force experienced by the trolley on the bullet. Can you see the average net force? Let me highlight this. This is very, very important. The average net force experienced by the trolley on the bullet is 591. So now the net force exerted by the trolley or exerted by the trolley on the bullet, so now is this one. So this one is the force that the bullet experienced. Okay, so this is the F net of the bullet that the bullet experienced, which is what? Which is 591. Okay, so let's talk. The bullet will experience a force going where? Okay, the bullet will exert a force that goes to the right on what? On the trolley, right? But the trolley will exert the force on the bullet that goes to the left. So now I want us to be in a position of understanding that if we choose going to the right as positive, therefore the average net force exerted by the trolley on the bullet will be negative, because now the trolley exerts a force that goes in that direction, but the bullet exerts a force going to right, but the trolley exerts the force that goes to the left. So it means now the net force here, we should be in a position of saying, okay, we can see that you have the net force, but your net force should be negative because it is acting in the negative direction. Okay, the net force that the bullet experiences. Okay, so this is the F net of the bullet that it experiences. Okay, very, very key. Very, very, very key. They now say the bullet trolley combination now moves to the right. So after this one was shot to that trolley, then it stuck inside, but they continue to move together as a unit. Okay. Therefore, they are asking us now 17.1. They say write down the magnitude and direction of the average net force that the bullet exerts on the trolley. Okay. So now if you are told that the average net force exerted by the trolley, okay, exerted by the trolley on the bullet is this one. So it means the average net force that the bullet exerts on the trolley will be negative of that. Okay, will be negative of this. So we will say, okay, actually, it will be opposite of that, right? So it's gonna be, the magnitude will be the same. The magnitude will be the same. Let me be in a position of answering that. The magnitude will be the same, which is what? 591. So magnitude and direction, right? The force is the same, 591 newtons. But now the question is, where is the bullet exerting a force? In which direction is the bullet exerting a force on the trolley? In which direction? In which direction is the bullet exerting a force on the trolley? Can you see the bullet is moving in that direction? So it's going to cause a force that goes to the right on what? On a 2.7 kilogram block. Okay, so the block will experience a force. Can you see? Will experience a force of 591 newtons to the right whereas now the bullet will experience a force from the trolley, will experience a force of 591 newtons, but now in opposite direction thereof. How very, very interesting. So this will be to the bullet exert on the trolley to the right, because the bullet is moving towards the right. 17.2, calculate the magnitude of the velocity with which the bullet strikes the trolley. Okay, calculate the magnitude of the velocity with which the bullet strikes the trolley. Now we need to check the information that we have. Can you see now? I do not have the velocity of the bullet initial. I do not know. I also do not know the velocity final of both of them. So is it a right choice to choose conservation of linear momentum? No, because I will have two unknowns. Which other option can I use? I can use F net is equal to change in time. F net change in time is equal to change in P. Why? Because I have the F net. I also have the change in time. Oh, all right. So now, but we went off the what with which the bullet strikes the trolley. So we'll say, okay, F net change in time, it is equal to change in P. Okay. Okay, let us be in a position of saying, okay, let me manipulate this F net, change in time, it is equal to mass final velocity minus final initial. But we want the what? The velocity with which the bullet strikes the trolley. So this will be the mass of the bullet, if you specify that. Mass of the bullet. Okay, yes. But now the force that the bullet experience, it is how much? It is 591. Okay, but remember, okay, choice of direction, you chose right as positive. But we need to know the bullet. This will be the F net of the bullet because we are calculating for the bullet, right? So we want to understand the F net that the bullet experiences. Is it moving to the right or to the left? Let us confirm again. I'm gonna say when the bullet goes in that direction, the trolley moves in the opposite direction, right? But now, can you see that the bullet will exert a force on the trolley that goes to the right? So it means now the force, the F net of the trolley will be to the right. Okay, the force that the trolley experience is to the right. But now the net force that the bullet experiences due to the trolley is to the left. Why? Because now trolley X is moving towards, sorry, the trolley is moving towards the left, and it collides with what? With the block. So the block will experience a force that wants to move it towards the left. So this is what I want you to understand. Therefore, how is this helping us? This is helping us in the position where when I come here, I'm going to say the F net that the bullet experience, it is negative. Why? Because I chose right as positive, but your net is moving towards the left. The F net is moving towards the left. So it's going to be what? It's going to be, oh, okay, I need something. I need to know something first. Calculate the magnitude of the velocity with which the bullet strikes the trolley. Okay, if I can, I want to see something. Oh, okay. Remember, the bullet will come to rest. Okay, the bullet comes to rest in the trolley. The bullet comes to rest in the trolley. So it means now the final velocity of the bullet, it is equal to 0 meters per second, because now it comes to rest. So this is the final velocity of the bullet. The F net is going to be 591. Okay, then the change in time, remember they told us that in 0.02 seconds. So this was the collision time and all of that in 0.02 seconds. Okay, then what is the mass of the bullet? It is 0.03, if I remember very well. Let me just confirm that. Yes. Then now final velocity, it is 0, it comes to rest. Then initial velocity, it is like that. And you should be aware that the answer that I get, it should be positive. Why? Because it is moving towards the right, and I choose right as positive. If the answer is negative, then clearly I did something wrong. Okay, yes. So here, this will be negative negative 591 multiplied by 0.02, I get something like negative 11.82. It is equal to 0.03 minus multiplied by negative VI. 0 minus VI, it is negative VI. So you'll get negative 0.03 VI. So when I check my VI, okay, remember this is VI of the bullet. VI of the bullet. They want the magnitude, or yes, the magnitude only. So they want the magnitude only. It will be 11.82 divided by 0.03. I get an answer of 394 meters per second. Do not get scared when you get this value. Remember, if a bullet can run at a very, very high speed thereof. So it is very, very correct. So the answer is 394 meters per second. This is the velocity, the magnitude of the velocity with which the bullet strikes the ground. If they wanted the direction, we're going to say what? Right. If they wanted the direction, we're going to say right. So this is us being in a position of substituting any of the formula here, then substitution here on the left, substitution on the right, okay, on the right, like that. Try to check the information that you have before you use any type of equation, okay? And it is very, very important for you to write down your your data like that, okay? Now, here they are saying state the principle of conservation of linear momentum. Then there are chances that you're going to use it after stating it. So you know that the conservation of linear momentum in an isolated, the total linear momentum in an isolated system is conserved, right? Stated. 17.4. I repeat, what is the conservation of linear momentum? The total linear momentum in an isolated system is conserved. Now, 17.4. They say calculate the magnitude of the velocity of the bullet trolley combination for both of them after the collision. So now, since when the examiner told me to state that there are high chances I'm going to use it, can I use it? Yes, I can use it because now I know the velocity of this one, which is 394. Okay, 394 meters per second. And I know for this one, and I can calculate for the both of these, since they are moving as a unit. Then I can say, okay, this time I'm in a position of saying sum of momentum initially, it is equal to sum of momentum final. What is that? That is mass of the bullet, velocity of the bullet initially, plus mass of the truck or trolley, velocity of the trolley initial. It is equal to mass of the bullet. Okay, you see, they are moving as a unit now, combination. So it's going to be mass of the bullet plus mass of the trolley. They have the same velocity there of velocity final. Very, very important. Therefore, when I substitute, what is the mass of B? Mass of B, I have forgotten about that. Or mass of the bullet is 0.03. And the value, remember, I need to choose the direction. So I'll choose right as positive. So it is 0.3 and the velocity is 394 in that direction. Mass of the trolley is 2.7. Then the velocity of the trolley, it is negative 3. Why? Because it is moving in an opposite direction, and then I choose right as positive. Your net is moving towards the left. So hence I put negative there. Therefore, what is the combination of their mass? It is 0.03 plus 2.7. Then I get something like VF, okay? Then what I want you to do, I want you to punch use your calculator and use this division, the division sign, okay? On the numerator, punch this side, this part, okay? So you'll say it is into 0.03 multiplied by 394 plus into 2.7. Remember, into it is a bracket. Into 2.7 multiplied by into negative 3. Therefore, divide. On the numerator, you're going to divide by all of this, all of that, which is 2.7 plus 0.03. Then you get a unique answer of velocity of these ones. Velocity final, it is equal to 1.36 meters per second. Let us see if the examiner asked for the velocity or the magnitude of the velocity. Therefore, you just leave it like that. If they wanted a direction, can you see that the answer is positive? You're going to say, therefore, right. If they wanted the direction. Therefore, substitution on the left-hand side, right-hand side, like that. Then any of these formulas, 1 mark. You do not need to write both of them, but it will be advisable. Okay. Very, very important. Choice of direction, important. Okay. In high school, they do not penalize you if you do not do choice of direction, if you do not show the direction, if you do it in your head. But in university, if you're going to be continuing with physics and all of that, engineering and all that courses, that, yeah, you need to tell the examiner which direction are you choosing so that the examiner can see now the why are you substituting negative for that particular which one and all of that. So yes, that's all from me. Let's meet on the next video. I hope you enjoyed. Thank you.